You identify a value of h and k, you identify a value of a, and then you can sketch the graph from that, or you can identify the graph from that. So for example, if we want to look, we're just going to look specifically at square root functions and cube root functions. So I mean, these are sort of like the equivalent of vertex form, right? We'll call this, I don't know what we'll call it, but we'll just say that I don't know what you'd even call this.
Standard form.
I mean, it's kind of like a standard form, but for a square root function, it's just this. We would just say that y equals a times the square root of x minus what? What do you think? H.
H. I was right. What?
Plus k.
Oh, okay.
And we just need to know what a and h and k mean. Okay, so here it is.
Is still a slope?
A is like the slope. It's not really a slope, but it's like the slope. So h and k are the coordinates of the special point, of the one unique point for a square root function, which is its start. So for example, if we wanted to graph something like y equals, let's say 2 times the square root of x minus 3 plus 4, then that just means that we're going to go over to the point, h and k are 3 and 4, aren't
Yeah,
they?
so
Right.
3, 4. X equals 3. K is.
So we're going to go over to the point 3, 4, and that's going to be our starting point.
So
Okay.
we're gonna go, like, is it gonna be the same sort of deal like that A could be the same sort of deal that we did with parabolas?
It's very, very, very similar. So once we find that point, the shape, so I'd like to see all the phones and everything should be totally away, please. I don't want to see Annie, no one should be distracted right now. I want everybody's attention up here, please. So, just like for a parabola always had, for graphing a quadratic function, it always has the same basic shape. It's parabolic, right? Same thing is true for a square root function. It always has the same shape. It's going to start at its starting point, and then it's going to do that. It starts off increasing rapidly, and it flattens out. Okay, and that's what it looks like. So the starting point is here. What does A tell you? A tells you that if you scoot 1 to the right, what does the function do? Does it go up or down, and by how much? So if A in this case is positive 2, then that means if we go 1 to the right, we're going to go up by 2. And so there's my second point, and that defines the shape of the curve. Then the curve just looks like this, just starts there and does that. That's it. How simple is that?
Okay.
So you define h and k defines the starting point. A defines how much the function is stretched, and the point, there's an easy way to do that. Remember, it's 1 to the right, and how much we're going up or down. What if this had been a negative 2? What do you suppose that would have been?
It's gone the other way.
Yeah. Does that make sense?
So
Okay, then it would have just gone, instead of going up 2, we would have gone down 2,
Like that.
and so the graph would have opened up downwards.
Look, it's
we're
probably.
like sketching it. We're not like
And it's,
graphing it.
and notice that if you look at those two together, it is a parabola. It's not an accident. A parabola is the graph of x squared. This is the graph of the inverse of x
So
squared.
this is just half of a parabola.
It is, just half of a parabola tipped on its side. Okay, so that's it. Okay, the other one then is a cube root function. Cube root function is almost identical, except it just doesn't start and stop. Oh, let's go back real quick, one more thing. What if I wanted to know let me go back just a little bit here.
Can it come to the left?
It can. The way it goes to the left is if you substitute negative x's for x's, but I'm not going to really mess with that for now. Yeah, well, maybe at the end we'll kind of talk just a little bit about that, but that's really not a big deal. What's the domain and the range? Okay, so if this is the function, The domain and the range we can see on the graph, but we can also anticipate what they are without even graphing it.
So X.
So what's the domain gonna be in this case? All the x values where the function is graphed.
So is it just the domain always, X cannot equal, K?
It's, well, no, look, what are all the x values of every point that I graph on this thing? X is greater than or equal to 3. And it's always gonna be, you can guess what it's gonna be right now. The domain is always gonna be x is greater than or equal to h, every time, right?
I meant H.
Greater than or equal to h. Now, what's the range? Range is the possible y values, the output values.
Study it forward, and then it would have a boundary for where the curve stops, right?
Well, okay, but yeah, so what are the y values? How would you describe the set of y values? Y is what? It's infinite, but like, for example, is y equals 1 in the graph of that? Part of the output.
So is I
No.
greater
What is it?
Wait.
Greater than or equal to 4, which is k, right?
Right.
Does that make sense? Okay, but you gotta be a little careful with this. If the sign of A is positive, the range is gonna extend upward, isn't it? From the
If it's
HK, the
negative,
special
it goes
point.
down, so.
What if A is negative? Then it's gonna extend downward. You see what I'm
So it'll
getting
be
at?
less than or equal.
So in this case, the range is y is greater than or equal to k, right? But if the graph extended downwards instead, if that A were negative and the graph opened up downward, like so, then the range would have been y is less than or equal to k. Okay, make sense? You can see those from the graph though, too, okay? What about cube root functions? Let's look at the same idea for a cube root function. Same format, y equals a times the cube root of x minus h plus k. Well, what do you suppose then, like if we take the cube root function, let's say y equals, same thing, 2 times the cube root of x minus 3 plus 4. What do you suppose that's going to look like?
Well, it's gonna start in the same place.
It's going to start in the same place, only this time the starting point is just a little bit different. So there's our starting point.
Right.
Okay, but it's not really a starting
Back.
point. It's a point of symmetry for a cube root function. Because cube root functions,
So it goes opposite.
they are defined everywhere. The domain of a cube root function is all real numbers. Now think about why the domain was restricted here. Well, this goes back to the previous discussion we had, right? Everything inside the purple bubble that's inside a square root can't be negative, can it? Right? So if we were trying to find the domain of this function prior to today, what we would have just done is just said, okay, well, purple bubble has to be greater than or equal to 0, right? Can't be negative. If I add 3 to both sides, I get x is greater than or equal to 3, okay? So it made sense there was a restriction because we got a red flag popping up. We're taking an even root, and we can't take an even root of a negative number, okay? Cube roots, no problem. Cube roots are odd roots. There are no restrictions, are there? Right? So the domain is everywhere. What does that do to the function though? Well, it's basically the same. If I think about what A is still sort of like the slope. It tells us if we go 1 to the right, how much are we going up or down? So if we go 1 right, we still go up 2. So the shape on the right is almost identical. It looks, you might even think when I draw it that it's the very same thing, but it's not. It's a little bit more sudden and abrupt. It starts off being a little steeper and it ends up flattening off just a little bit quicker if you compare the two, but they have basically the same shape. Okay, but so this is probably, it's kind of just rounded like that. So what's it gonna look like on the other side though?
1 to the left, 2 down?
It's gonna go, right, on the other side, it's gonna go back 1 and down 2. So A tells you two things. It tells you how far you're gonna go up on the right if you scoot over 1, and how far if you scoot 1 to the left, you go down, okay? So if we go back 1, we're gonna go down 2. And so here's what the other half of that graph looks like. Now this has rotational symmetry. In other words, if I put a tack right in the center and spin it 180 degrees, it lines up with itself, right? Okay? Make sense? Now, what's this gonna look like if that were a -2?
Opposite. So
Opposite in what way?
the one that goes to the left will be on the top, and the one that goes
Okay.
to the right will be on the bottom.
Good. Now, listen to how we say that. When we go to the right, it goes up by -2. Okay, that means down, doesn't it? When we go to the left, it's going down by -2. Going down by -2 is equivalent to going up by 2. You see how that works? So then we would just have, that, right? Makes sense? So all you're gonna do on the assignment, it's a really short, simple assignment. All you're gonna do is just, in some of these examples, like, let me pull up, I'll just pull up this guy. I'm gonna give you a cubic function, and you're just gonna pick the graph that goes with it. Okay,
It's not the top one.
no big deal. So you have to just identify here, obviously, what's H and K and A.
Oh, yeah.
I mean, it couldn't be easier. And then on the other part of it, I'm gonna give you a graph and just ask you to write the function and write the domain and the range. But, big deal, right? This is
It's the top one.
far and away, it's probably the easiest assignment maybe you've had all semester. I mean, it's not, this is a really, really quick
Oh,
one.
no, switched. It's not the top one, because
Not the top one, is
it's
it?
trying to mess with you, to think, if.
Yeah, though it's,
if
I
the
believe me, I
HTK
tried
was-
to, I messed with you. I mean, they're all gonna look like
Two-shape X.
reasonable candidates, but
Yeah.
that's,
The top
let's
one, I
see,
thought was right.
it's over 2 and down 5, so that's it right there, isn't it?
No. that's
Over
three.
2, oops, no, it's not. That's not it. Where is it? Right,
I can't
that's
see
not it either. Boy, I messed with myself.
Wait, bottom. Going down. No, it's not it.
No,
No, the Y has to be.
there it is,
positive.
right there. That's it. Over
It
2,
has to be two.
down 5 to the symmetry point, right?
That was right.
Because H is 2, K is -5, and A is +2, so we go over 2, over 1 and up 2. So that would be it, see what I'm getting at?
Let's go.
All right, 209.